Hey there, you 12. So in this video here, I'm now going to show you, instead of doing the table method, so whilst the table method's nice, you can read from the table and you can also then practice from your textbook because they're using the table method. Remember that in the exam, they're not going to ask you, generally they don't ask you to do table or this second method here. So you can choose which one you want to do. Clearly, I'm going to show you this next method and it's going to be faster than the table, but the table is a bit more structured, if that makes any more sense. You're essentially doing the table, but more visually, that's all. So less of this, follow this, writing this down in a table. You don't need to do that. But essentially, it's the same idea. Okay, so here we go. Let's say if you didn't do the table and you were to just to look by inspection. Okay, so it's not about trial and error where you just do this, here, there, to get from A to F, and then you might go, oh, what about if I went this way, like that, or you went from here to here to here, then went from here to here to here, and then what's another option you can do? You might go from here to here to here to here. There's no testing, okay? You don't want to be testing every one of those values. There has to be a systematic way. So this is Dijkstra's algorithm, but I guess by inspection. So how you would do this by inspection, you start off with A. Okay, we start off with A. And you say, well, what routes are connected to A, right? So we've got currently B is connected to A, and we've got C that's connected to A, right? That gives us a weighting of 2 and 6. Now, out of 2 and 6, which one is the smallest route, okay, that's connected to A, and the A doesn't connect to anything else, right? So very similar to the table. Remember, once you box it, you've already determined the best route possible. Okay, so clearly I can see out of 6 and 2, 2 is the next best route. Notice I deleted the edge, but I kept the weighting of 6 to remind myself that was a distance of 6. Yeah, so 2 is the best route so far. So I'm going to highlight this. I'm going to say, all right, A to B is the best route that I can get so far. Okay. Then I say, all right, well, where else can I go? So it seems like B is where I'm starting off, because remember, I'm circling this as my next best route. So 2 is my next best route. I'm going to put a circle around it to remind ourselves that we've boxed it. So B is the best route. And then I go, okay, from B to C, what is that? So B is currently at 2. If I go to C, that's an extra 2, which makes it now 4. So 4 is clearly a better route than 6. So I can delete the 6, or I can just leave it there for now. All right, but that's a 4. And then what about from B to D? I can connect B to D, which gets us an extra 3, which makes this 5 now, right? And then what about E? I can connect B to E, which is an extra 2, which makes this now 4. Now, out of these 2 routes, or all these 3 routes, sorry, so you remember you had 4, 4, and 5. Which one is the best, next best weighting? Clearly 4s are. So that's why you can choose any pathway. You can choose the 4 up here or the 4 down there, or if you like, since they are both 4s, you should highlight them both. Okay, so those are the 2 best routes. So it's kind of similar to the table. Remember, we had 2 4s, and I said you can choose the column, doesn't matter which one you choose. In this case, you essentially highlight them both. Okay, so 4 is the next best route. So I'm going to keep the circles here. I've already determined that E has a best route of 4 and C has a best route of 4 over here. So I keep that as 4. And then what is my next point? Well, I need to start off from 4, right? 4 is the next best weighting. So from 4, I then say, all right, well, what about E towards D? That's an extra 2. So 4 plus 2 makes it 6 now. Okay, but 5 is still my better route there. So from E, I'll just leave the 6 there just to remind ourselves 5 is clearly the better option. And then from E to F, that's an extra 3, which gives me now this weighting. 4 plus 3 is 7. So that now makes it 7. Okay, and remember, I started off at E because it had a 4, but then this also had a 4 as well. So I need to also calculate that distance. From 4 over here, if I went to D, that was also an extra 1, which makes it a distance of 5 again. Okay, now you look at all of them again. Okay, you look at all those distances again. If it helps, I'll rub out this these lines to help you visualize a bit more. Out of all the numbers, which one is the next smallest value? Okay, so I've already circled 2, I've already circled 4. What's the next smallest value? We've got 5, 6, and 7. Clearly, 5 was the best route. Okay, so 5 is the one that I'm going to circle now. And I'll say, all right, well, how did I get 5 again? I got 5 by going down E to D. Okay, so E was 4, and I went down, not E to D, sorry, my bad. 5 was from 2 to B, so A to B, and then B to D. That was one route. 2 plus 3 is 5. And the other route was A to B, B to C, and then C to D, which gives me that route there. Okay? And then since 5 is my next best route there, I start from 5 and I say, all right, well, where can I connect to? There's no point going to E because I've already ticked off E. E's good. E's 4. B is 2. C is 4. So I don't need to go to E. The only other vertice left I have is F. So from D to F, I need to calculate that's now from 5, an extra 5. That makes 10. Can you see that? So 5, adding an extra 5 gives me 10, but remember, I've got a 7 here. And that 7 was from E, which is 4 plus an extra 3. So clearly, my next best route now is 7, and that finishes all the vertices. So I now know E, I'm going to highlight to F. So E to F is the next best route. So what you see here in this diagram gives me the best route for all of the vertices without using the table. You see that? I've got 2, 4, 4, 5, and 7 through inspection, and I followed a systematic way where I'm looking for the best value, which is the smallest number that you can get each time I went. Okay? What's tricky here is that along the way you might lose track of which numbers, which pathways with which. So kind of like the one before I said 5. How did I get 5? I had to kind of backtrack a bit to find 5, whereas in the table, it becomes a bit more clear, right? But when you're doing this by inspection, it'll be much faster, okay? Even as I'm recording this should be much faster. I'm pretty sure the other ones were about 10 minutes to 15 to explain, whilst this one I'm already done at 7 with explanation. So it means when you do them, you would go through them faster. So you can see the highlighted diagram here that I have is pretty much the same as the previous example up here, okay? So this is Dijkstra's algorithm now, but not the table method. This is by inspection method. Okay? So hopefully that gives you an idea. I'm going to do a few more just so you get an idea of Dijkstra's algorithm by inspection.